Okay, we'll look at some of the problems that are in section 9.3. Excuse me. And I'm only going to look at only 3 problems like this first one. In a city, the probability that it will rain on a certain day is 0.8 if it rained the day before. The probability that it will be dry on a certain day is 0.2 if it was dry the day before and it rains on Sunday. Okay. All right, now let's take a look at this problem here. It says here, according to the digits, and by the way, let's look at the random digits here that were given to us, and just simulate the weather for the rest of the week, with the first digit being Monday, the second digit being Tuesday, and so on. And if you have digits from 0 through 4, that represents the first 0.5 probability, and 5 through 9 represent probabilities of 0.6 to 1. Okay. Now, according to the digits here, will Monday be rainy or dry? In this case, now we're told in this particular problem that the probability that it will rain on a certain day will be 0.8 if it rained the day before. And here it rained on Sunday, so on Monday, we can predict that it will be raining. Simply because it rained on Sunday and we're told that the probability that it will rain on that day will be 0.8 if it rained the day before. Okay. Now, problem number 2. Here's the next example. Given that Monday is rainy, will Tuesday be rainy or dry? Okay, it rained on Monday, so that means the probability of Tuesday's weather would also be raining because it rained the day before. Okay, so there's a probability that it will rain on Tuesday. All right, next problem is given that Tuesday is rainy, will Wednesday be rainy or dry? In this case, it's also going to be rainy as well because it rained the day before. And for the same reason here, given that Wednesday is rainy, will Thursday be rainy or dry? In this case, the same thing. It's going to be rainy as well because it, of course, rained the day before. Okay. Now here's a problem that was similar to the one that's in your book. And this is one of the examples, well, similar to an example that was in your textbook that I went over on the slide. And this deals with estimating the population of a certain number of fish in this case. Let's say here, to determine the number of trout in a lake, a conservationist catches 320 trout, tags them, and releases them. Later, 145 trout are caught, and it is found that 85 of them are tagged. Estimate how many trout there are in the lake. Okay? Now, with this particular problem, we're going to have to work backwards to find out how many trout there are in the lake. Now, we're told that 85 of the 145 are tagged because we caught 145 and 85 of those trout are tagged. So here, as a fraction, it'll be 85 over 145. And this will be reduced in its simplest form. Okay. In this case, in simplest form, it'll be 17 over 29. Okay. So here, 17 over 17/29, so those fish were tagged, or the trout were tagged. Okay, now we're going to find out the number of trout that are in that lake. So we're going to let N be the number of trout in the lake. Okay, and we know that there were 17 over 29 that were in that lake that were tagged originally. So we're going to take 17/29 and then multiply that by n, which is the number of trout in that lake. That's going to be equal to the number of trout that the conservationists originally caught, which was 320. So now we have an equation: 17/29 times n is equal to 320. Now to solve this equation, what I'm going to do here is multiply both sides by the reciprocal of 17/29, which would be 29 over 17. Excuse me. When I do that, I'll have n that's going to be equal to, now I'm going to do 320 times 29 divided by 17. Which will give me, now as a decimal, it's going to give me 545.88. But we're going to round to the nearest whole number, which is going to be approximately 546. So in this case here, there are 546 trout that are in that particular lake. Okay. All right, here's another problem that's similar to that trout problem that I just did. And this is the last problem here in this homework set. To determine the number of trout in a lake, a conservationist catches 103 trout, tags them, and releases them. Later, 107 trout are caught, and it is found that 85 of them are tagged. Estimate how many trout there are in the lake. All right, again, we're going to be working backwards for this particular problem. And we're told that there are 85 of the 107 trout that were later caught were tagged. So as a fraction, that would be 85 over 107. And that fraction is already in simplest form. Okay, now what I'm going to do here is find out how many trout they were in the lake originally. So we're going to let n be the number of trout originally that were in the lake. Now we already know that 85 out of the 107 were tagged, so let's do this. Take 85 over 107, multiply that by n, that would give us, in this case, 103. Because originally the conservationists caught 103 trout. So let's find out how many trout originally there were in the lake. So it'll be 85 over 107 times n is equal to 103. And just like I did in that problem, I'm going to multiply 85. Well, I have to get the n by itself by multiplying both sides by the reciprocal, which is 107 over 85. So in this case, I have 103 times 107 divided by 85, which is in this case 129.65, well, 66, 129.66. Now, to the nearest whole number will be 130. So in this case, there are 130 trout in that lake. Okay. So these problems should be able to assist you in doing the actual homework problems that are on the MyMathLab website.